So in this problem, we have a combustion equation. The chemical is called hexatriacontane, and the question says, the combustion of hexatriacontane, C36H74, proceeds with the following stoichiometry. I've given you the balanced equation, and incidentally, when you want to balance an equation, a combustion equation, and you're burning a hydrocarbon, the easy way to balance is to always proceed alphabetically. First carbon, then hydrogen, then oxygen. So there are 36 carbons in hexatriacontane, so I'm going to end up using, well, the way I balanced it to begin with, let's start by erasing this to show you how I worked it through. There's 36 carbons in hexatriacontane, so I start off by putting 36 carbons on carbon dioxide. 36 carbon dioxides, because that's where the 36 carbons are going to end up. 74 hydrogens means you need to put 35 plus 2, 37 waters, because each water has 2 hydrogens, times 37 is going to give you the 74 hydrogens you're looking for. Then I'm going to balance oxygen last. So 36 times 2 gives you 72, plus the 37 gives you 109 oxygens. So if I put 109 in front of oxygen, that's going to give me twice as many oxygens as I need, because oxygen is diatomic, so I'm going to put it over 2. And if I want to get rid of the fractions, I can just put a 2 in front of this, erase the over 2 part, double this, and double that. And this ends up being 60 plus 14, 74. And now we have it balanced using only integer values. We're told in the problem that there's 200 grams of hexatriacontane, that it burns completely in the presence of oxygen. So what we do first is divide by the molar mass of this substance, hexatriacontane. So there's 36 carbons, 74 hydrogens. 200 grams divided 506 grams per mole gives you 0.39 moles of hexatriacontane. Then in the fourth step, I want to switch from moles of hexatriacontane to moles of oxygen, moles of water. So the way I achieve that is by using the stoichiometry. The stoichiometry is 74 to 2. There's 74 water molecules for every 2 molecules of hexatriacontane, so I get 14 moles of water. I then multiply by the grams of water per mole, and it tells me 262 grams of water. I then report the answer to 3 significant figures, and we're done.
Any questions?